What's happening, dogs? Mr. Allen here with some graphing of absolute value functions, but we are given this stuff in function notation, which is kind of interesting. We'll deal with it. All right, we want to graph each one of these functions, describe the transformations from the parent function, f of x equals the absolute value of x, and we're going to talk domain and range for these guys. So first one here, g of x equals negative f of x plus 2 plus 4. What's with this weird notation? Well, you can actually have this set up here really for any type of function, whether it's absolute value, quadratics, linear, you name it, and we can just kind of input our function. I'm going to rewrite this thing. You don't have to do this, but I'm going to do it, all right? So we got g of x is equal to, then it would be negative. My function is the absolute value function, so x plus 2 plus 4. So there we go. I've just rewritten it. Now it looks a little more normal, right? And perhaps now you can see the transformations and things like that. You can do all this stuff from the previous form there or rewrite it if you'd like, or maybe your teacher will even ask you to rewrite it. All righty, so let's talk transformations here. What's that negative going to do here? That's going to be a vertical reflection, okay? So vertical reflection. Some might say reflection over the x-axis. That works too. I'm going to go vertical reflection. What's this guy right here going to do? That's going to go to the left 2. So left 2. And then what's that 4 going to do on the outside? That's going to go up 4. And you might be like, wait, hold up. Why do we go to the left 2 when it's positive 2? On the inside, it is the opposite, okay? So we have to think about what we're adjusting for. If I were to plug in negative 2 here, I would get 0 in the absolute value, getting it back to like its original state. So negative 2 would be left 2, all right? So it is the opposite down there. Always a little bit of a spot to get tripped up, but it'll be just fine, okay? So let's go ahead and graph this thing. I like to start with the vertex of this absolute value function, which is to the left 2 and up 4. So left 2 and then up 1, 2, 3, 4. Okay. Then, because of this negative here, instead of going up like this in a V shape, we're going to go down 1 over 1 and down 1 over 1. My transformation's almost gotten away there. And we can do two more, or another pair of points if we want, or really, this should be about all you need. Your teacher might ask for 5 points. 3 is really enough for me because that makes the V shape. All right, some graphs you want to get some more points, but whatever your teacher tells you, I would go with that. Okay, but there we go. We got ourselves a nice little graph. Let's talk domain and range. So domain's all my x values. Does it ever stop going to the left and to the right? No, it keeps going left and right. So x is going to be equal to all real numbers. Another way you could write this is a different notation. You don't have to write both of these, is negative infinity to positive infinity. Okay, that's interval notation there. This is like set builder notation, kind of on the, not as formal end. Sometimes you got like fancy brackets and all these different things. I think that's enough. X equals all real numbers. That's my go-to. Interval works as well. Range, does it ever stop going up or down? Yeah, it gets to a high point of 4, right, where my vertex is. So the highest it gets is 4, and it goes down to negative infinity, okay? So what we could say here is that y is less than or equal to positive 4, or if you are to use the interval notation instead of what we have here with the inequalities, it's going to be from negative infinity to positive 4. Okay, always from least to greatest with the interval notation. You wouldn't want to start with the 4 and go to negative infinity. You got to go from least to greatest there, all right? Now, one last thing I did want to talk about on this one here is if you're like, I didn't feel comfortable doing this with the transformations, I'm more of a T-chart person, you can always do a T-chart, guys. You don't have to. Your teacher might ask you for a table of values, a T-chart. So the way that I do these is first it's going to be my vertex, which I know is at negative 2, positive 4. That's going to go right in the middle there. That's this point right up here. And then I'll pick a point to the left and to the right. So negative 3 and negative 1. When I plug negative 3 in, negative 3 plus 2 is negative 1. The absolute value of that is positive 1. But then it becomes negative again. Negative 1 plus 4 is 3. And if I plug the negative 1, the same kind of thing happens. Negative 1 plus 2 is 1. Absolute value of 1 is 1. But then it becomes negative out there. So negative 1 plus 4 is positive 3. And you see those points there on our graph. But T-chart can work. You can just do it with the transformations and some movement of that graph. Really up to you unless your teacher is requiring you to do one way versus another. Okay? Nice. Beautiful. Fantastic. I'm going to go with the blue marker on this next one here. We got ourselves another one with 3 transformations. So what's this guy right here? There's a couple ways of writing this. You can either think of this as a vertical compression. That's my choice. Vertical compression by 1/3. Some may even allow you to just say dilating by a factor of 1/3, which does, shrink it like this. Up to you. Double check again with your teacher on what notation. Either vertical compression by 1/3 or dilating by a factor of 1/3 would be appropriate here, okay? In here, we're going, let's see here, to the right one. So right 1, and then we're going down 2. Note that I didn't even rewrite this one as in the absolute value form. I'm just going straight up off of the transformations here, which I think is just fine. So let's go ahead and do that. So my vertex is going to be to the right 1 and down 2. So right 1, down 2. Then what the heck do I need to do here to make this V shape? It's going up, it's going down. Well, it's positive, so it's going up. But that 1/3 is going to shrink it. So for every 1 that it goes up, it's got to go 3 over. So up 1 and then over 1, 2, 3. So it's going to look a little more spread out here. 1, 2, 3. And we've got this lovely wide V shape. 1, 2. Yeah, we did. Okay, we're good. Nice. Look at that. That's beautiful. That's fantastic. All right. There we go. So could do a table of values if we wanted. I'm not going to do it on this one. But let's talk domain and range here and then call it a day. My domain for all absolute value functions, it's going to be all real numbers. Okay, which again can be written like this or in interval notation. Either one's cool. You do not need to have both. These are just two different types of notation, pending what your teacher uses or requests. Up to you. I'm cool with either of them, as long as you get the job done. All right. Range. Does it ever stop going up or down? Low point is -2. So my range is going to be y is greater than or equal to -2. I am including that point there. And then interval notation will be starting at -2. Whoop. What is that? That is not -2. My goodness. Let me see if I can just erase that real quick. Pretty good. Okay. -2 to positive infinity. I wanted to write the infinity first. That was funny. All right. Cool, man. There we go. So just different style. They can ask you any one of these any questions, in a test type of thing. They might just give you this and say, what are the transformations, right? They might give you this and try to match a graph. They might have you do the whole shebang and get the whole graph or whatever. So when we do these problems like this, where there's a lot of stuff to it, keep in mind there's, like 4 or 5 different questions we could ask you on a test to break things up to see what you know. Like I could just give you this and say, what's the domain or what's the range? You have to be able to identify those things given these different functions. Awesome. Fantastic. Wonderful. That was a dope time, you guys. I hope you enjoyed it as much as I did. I had an absolute blast. Have a great day.